we want to find the limit of this, okay? I'm going to go over here and write it as x. In fact, I'm going to say y equals the limit as x goes to infinity of x plus 5 over x raised to the x power. Now, we have a problem here. Inside the parentheses, anybody tell me what that limit is approaching?
0.
It's got x on top and x on bottom.
Oh,
1, right? It's like the polynomial thing. The highest degree, 1 over 1. Okay? So, our intuition might think, well, this is approaching 1, and 1 to the infinity is 1, so it's going to be 1. That might be our intuition. But as we saw here, this is approaching 1 inside here, because that's going to 0. And the limit is not 1, is it? No, it's not. So, what's this going to be? Well, it might be something with e, but there's no guarantee. There's a 5 there, so does that mean it's going to be e? Not necessarily. Well, here's what we do. We take the natural log of each side. You see, we need to get this x down. The only algebra tool we have to bring an exponent down are logarithms. That's the only tool we have to do that with. So anytime you have a variable in the exponent position, not a number, a variable, and you need to get it down, logarithms are your only option. Okay? So we're going to do ln, natural log, of each side. Now remember, natural log is just log with base e. This in science, this happens so often that it got its own notation. So it's just log with base e. That's all natural log is. So we're going to take natural log of each side. Like that. And now we're going to bring this x. Actually, let's rewrite it again. There is a property. I'll show it with something simpler here. There is a property of limits that you learned in first semester calculus. When you have the limit of, let's say it's n goes to infinity of x to the n, it could be written as the limit as n goes to infinity. Wait, am I thinking right here? No, let's not do n here, I'm sorry. The limit as x goes to infinity of x squared, let's do that. It could also be x squared this way. Does that make sense? So a function applied on the inside can be moved to the outside. Likewise, if you have square root x in here, it could be square root of the limit. So that function applied to x on the inside could be applied to the outside. There's a property of limits you learned in first semester calculus that says that. So likewise, if it's on the outside, it can go in. So I'm going to take this logarithm and write it on the inside. Like this. And then we can bring this x down. Like that. natural log, they bring the n down. Oh, I see what they did. This inside here, this x plus 5 over x, that's like x over x plus 5 over x, right? And that's 1 plus 5 over x. So this part inside that logarithm there can be written as 1 plus 5 over x, like that. And then we have x in front. What's this approaching inside these parentheses?
Just one.
1, right? That's going to 0, so we're going to have natural log of 1. What is natural log of 1?
0.
0. And x is going to infinity, so we have infinity times 0. That's the form here, right? So this is of the form, or type, infinity times 0. Let's take it over here. I'm going to rewrite that. Limit as x goes to infinity of ln 1 plus 5 over x over 1 over x. Do you see when we're dividing by 1 over x, we can multiply by the reciprocal and get that back? You guys all right with this move? Is that okay? Now, it has the type or form 0 over 0. Because this is going to 1, that goes to 0, so we got 1 in here. Natural log of 1 is 0, and as x goes to infinity, this goes to 0. Once we get 0 over 0, what do? L'Hopital's rule. If we get it into 0 over 0 or infinity over infinity, we can use L'Hopital's rule. So, L'Hopital's rule. Okay, review here. What is the derivative of ln x? 1 over x. So here, the derivative of ln of this is going to be 1 over this times the derivative of this. Got to do chain rule. The derivative of 1 is 0. The derivative 5 over x. What's that going to be? Well, that's like 5x to the negative 1. Bring the negative 1 down, you got negative 5x to the negative 2, so that's negative 5 over x squared. So the derivative of 1 is 0, the derivative of 5 over x is negative 5 over x squared. So that's chain rule. Over, how about the derivative of 1 over x? That's like the derivative of x to the negative 1. Bring the negative 1 down and subtract 1, which is negative 1 over x squared. So the derivative of 1 over x is negative 1 over x squared. We just did L'Hopital's rule. Erase this scratch paper work here. All right, now let's do this limit. What's the limit in here gonna work out to? Well, actually, let's not do that limit yet, but let's, what can we do here to simplify? When we divide by a fraction, we multiply by the reciprocal. So we got 1 over 1 plus 5 over x times negative 5 over x squared times the reciprocal of this, negative x squared over 1. These x squareds divide out. Negative times negative is positive, so we have the limit as x goes to infinity of, we have 5 left up there, over 1 plus 5 over x. This goes to 0, so this equals 5. But that's not the final answer. What equals 5? Yeah, natural log y is equal, natural log y could have come down on all these. Natural log y equals all this stuff. I'll write it with black here. ln y equals 5. Well, we're trying to find this limit, which we let y equal that limit. So we need to solve this for y. Whatever we get for y here, that's what that limit will be. How do I exponentiate this? What's the little base for natural log? Definition of logarithms, the base raised to that exponent equals this, right? So e to the 5th equals 5, equals y. Y is the limit. So now we have the limit as, and that is equal to this version with n. The limit as n goes to infinity of n plus 5 over n raised to the nth power is equal to e to the 5th. There it is. I think we should do another one of those. Streamline it a little bit. We'll do another one. Questions on any one of those steps?
When you got the 4 infinity to 0, what did you do for
So I took this, which is going to infinity, and I wrote it in the denominator as 1 over that. That's what, where did I do it at? So the x, if you move the x down below, it becomes 1 over x. That make sense? Because if you multiply by the reciprocal, it puts it back there. And so that's how we got this. Now we have the form or type 0 over 0, so we could use L'Hopital's rule. All right, let me put one up here. And let's do this example first, and then if there's time, I'll do another one more like this.